Learning objectives. At the end of this topic, you will be able to understand congruence of plane figures, congruence among line segments, and congruence of angles. Learn congruence of triangles and learn criteria for congruence of triangles: SSS, SAS, ASA, RHS. Congruency. Look at these two stars. They have the same shape and same size. Look at the second example. The two dice are of the same size and same shape. Now take 2,000 rupee notes. Place them one over the other. What do you observe? One note covers the other completely and exactly. Now let us define congruency. If two geometrical figures are identical in shape and size, then they are said to be congruent. Consider two parallelograms A and Z on the axis. Each side of the figure is same in length, and area of these figures is also the same. Therefore, the two figures are having the same shape and size. We can say that the parallelograms A and Z are congruent to each other. The symbol for congruency is congruence among line segments. If two line segments have the same, that is equal length, they are congruent. Also, if two line segments are congruent, they have the same length. Look at this figure. The line AB measures 10 units and the line CD measures 10 units. Hence, we can say that line AB is congruent to line CD. Congruence of angles. If two angles have the same measure, they are congruent. Also, if two angles are congruent, their measures are the same. Consider the example. Angle A measures 48 degrees and angle B measures 48 degrees. Therefore, we can say that angle A is congruent to angle B. Congruence of triangles. Two triangles are congruent if they are copies of each other, and when superimposed, they cover each other exactly. Look at the triangle ABC and the triangle RST. If we place triangle one over the other, it will cover each other exactly. The vertex A goes over vertex S, the vertex B goes over vertex R, and the vertex C goes to vertex T. The side AB coincides with side RS, the side RT coincides with the side BC, and the side AC coincides with the side TS. The angle A matches with the angle S. The angle B matches with angle R, and the angle C matches with angle T. Triangle ABC and triangle RST have the same size and shape, and hence they are congruent. Therefore, triangle ABC is congruent to triangle RST. SSS Congruence Criterion. If under a given correspondence, the three sides of one triangle are equal to the three corresponding sides of another triangle, then the triangles are congruent. Consider the two triangles ABC and DEF. The side BC is equal to the side EF. The side AB is equal to the side ED. The side AC is equal to FD. We can observe angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Therefore, by SSS congruency, we can say that triangle ABC is congruent to triangle DEF. Sas Congruency Criterion. If under a correspondence, two sides and the angle included between them of a triangle are equal to two corresponding sides and the angle included between them of another triangle, then the triangles are congruent. Observe the two triangles MNP and QRS. The side MP is equal to the side RS. The side NP is equal to the side QS. The angle P is equal to angle S. Therefore, by side-angle-side congruency, the triangle MNP is congruent to QRS. Asa Congruence Criterion. If under a correspondence, two angles and the included side of a triangle are equal to two corresponding angles and the included side of another triangle, then the triangles are congruent. Observe the two triangles ABC and A'-B'-C'. The side BC is equal to the side B', C'. The angle B is equal to angle B'. The angle C is equal to angle C'. Therefore, by angle-side-angle congruency, the triangle ABC is congruent to triangle A', B', C'. Rhs Congruence Criterion. If under a correspondence, the hypotenuse and one side of a right-angled triangle are respectively equal to the hypotenuse and one side of another right-angled triangle, then the triangles are congruent. Observe the two triangles ABC and DEF. The side BC is equal to side EF. Angle B is a right angle, which is equal to the right angle E. The hypotenuse side AC is equal to the hypotenuse side DF. Therefore, by right angle, hypotenuse side congruency, the triangle ABC is congruent to triangle DEF. In the given figure LMNO, LM is equal to 8.9 cm, LO is equal to 8.9 cm, LN is equal to 4.5 cm, MN is equal to 4 cm, and NO is equal to 4 cm. Examine whether the two triangles LMN and LNO are congruent or not. Consider the triangle LMN and triangle LNO. LM is equal to LO is equal to 8.9 cm. MN is equal to NO is equal to 4 cm. Ln is the common side, which is equal to 4.5 cm. By observing these measures, the three sides of one triangle are equal to the three sides of the other triangle. So, by Sas congruence rule, these two triangles are congruent. Therefore, triangle LMN is congruent to triangle LNO. ABCD is a parallelogram. Prove that triangle ABC is congruent to triangle ADC. Solution. We are given that ABCD is a parallelogram. By the properties of a parallelogram, opposite sides are equal. That is, AD is equal to BC and AB is equal to DC. Opposite angles are equal, that is, angle B is equal to angle D and angle A is equal to angle C. In triangle ABC and triangle ADC, the side AD is equal to side BC, angle B is equal to angle D, the side AB is equal to side CD. By observing these measures, the two sides and one angle of one triangle are equal to the two sides and one angle of the other triangle. So, by Sas congruence rule, these two triangles are congruent. Therefore, triangle ABC is congruent to triangle ADC, hence proved. Triangle PQR is an isosceles triangle such that PQ is equal to PR. Prove that the altitude PO from P on QR bisects PQ. Step 1. Consider the triangle POQ and triangle POR. Given PQ is equal to PR. PO is a common side. The angle POQ is equal to angle POR is equal to 90 degrees. By Rhs congruency, the triangle POQ is equal to triangle POR. If the triangle POQ is equal to the triangle POR, then OQ is equal to OR. Therefore, the altitude PO from P on QR bisects PQ. Summary. Let's summarize the topic. Two plane figures are congruent if each, when superimposed on the other, covers it exactly. Two triangles are said to be congruent if three sides and the three angles of one triangle are respectively equal to three sides and three angles of the other. SSS axiom. If three sides of a triangle are respectively equal to the three sides of another triangle, then the two triangles are congruent. Asa axiom. If two angles and a side of one triangle are respectively equal to two angles and the corresponding side of another triangle, then the two triangles are congruent. Rhs axiom. If the hypotenuse and one side of the right-angled triangle are respectively equal to the hypotenuse and a side of another right-angled triangle, then the two triangles are congruent.